Okay, so you guys should be familiar with the exponentials now, and what we're going to look at for logarithms is logarithms are what we would refer to as the inverse. That's the relationship that you haven't been introduced to yet. So this is the way the relationship works. If y equals a to the x, then the logarithm, we abbreviate it as log, that's the connection between the function and its inverse. Now this looks much more complicated than logs really are. So at this point, that's just a definition. You'll see how they're related better when we work through some examples. Okay, so let's take a look at what exactly this means. So when we're dealing with logarithms, it means we're looking for, well, if it's the inverse, it's going backwards. Normally, you give me a number for an exponent, and I give you a value. When we go backwards then, you're going to give me a value, and I'm going to tell you that the exponent is. So that's what logs are all about, is we're looking for an exponent. Okay, so that's what we're looking for here is when you hear logarithms, that's the first thing that should pop into your mind. They're only strange because they're new. Basically, we're looking for exponents. That's what a logarithm does. So here's some notation. This is the way it'd be written as. Log 981 equals 2. The way you'd read this to somebody was you'd say log base 9 of 81 is 2. Now that kind of sounds strange. So what does that mean? Well, that means that 81 is the second exponent of 9. And that was what I was looking for, because the logarithm says it equals 2. The logarithm is telling me the exponent, that's the connection between 9 and 81, is 2. 9 squared equals 81. Okay? So the good news is the base stays the same. If we're talking about a log in base 9, then as an exponent, the base is still there. But again, what you have to remember is when you hear logs, they're asking you about the exponent. So this is where the exponent appears when you're dealing with logs. This is where the exponent would appear when you're dealing with an exponential. So let's see if we can go back and forth and see if we can connect these two things together. Okay, so here's like some of the values you'd normally be used to seeing, like 9 equals 3 squared. Okay, so I'm going to do the first one for you because I know it's really strange when you first see logs. But this says the log in base 3 of 9 equals 2. Okay, again, it's asking me how is 9 connected to 3 by an exponent? 3 squared is 9. That's why the answer is 2. Okay. Can somebody tell me in English how you could say this as a logarithm instead of an exponent? Let's get someone on the east side. Someone who's woken up on the east side. Let's see. Steven, are you up for this? Give it a try. Give it a try. I'd like you to say this instead of an exponent, like 2 to the 4th exponent equals 16. I'd like you to say log base of equals
log base 2.
Excellent. Okay, you've done your part. You've done your part. I'll leave you alone now. Okay, somebody else. Log base 2 of Roger. You seem to find it particularly funny. Let's see. Can you give me the next number? Yes, log base 2 of 16. How are they connected? Jackie? 4, yeah. So this is the relationship. 16 is connected to 2 by the 4th exponent. Okay? And of course, there are other exponents, right? Like negatives. Negative 2 here. This would be the log in base 2 of 1/4 is negative 2. That's how 2 and 1/4 are connected by the exponent. Okay, so try the next 3 by yourself. There's a couple letters that show up in there, but that's okay. The letters still work the same way as long as you can do the connection. Remember, logs ask about exponents, so see how you do. Okay, so first example, let's see here. Andy, can you give me the first one here as a logarithm?
Log 10.
So, again, whenever you hear log, the important thing, I'm going to keep saying it until you're really annoyed with me, and all you do is say, God, all Mr. Joyce wouldn't shut up about logs and exponents. Log is an exponent, 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 because that's the connection you need to make with this new idea. How is 10 connected to 1 over 100? It is this negative 2 exponent. That's the way it works. Yes?
How do you change the exponent thing on your calculator?
We will talk about calculators and logs shortly, but not just yet. 8 equals 2 to the x. Okay, Alice, go for it.
Log base 2 of 8 is x.
Anybody know what x is? 3 is correct, yeah. Okay, the next one, x equals 3 to the 5. Okay, Jackie? Uh-huh. That's correct. Okay, so that's the first important step, is to make that connection. Now let's see if you can go backwards. Okay, so I'm going to do the first one with you. 3, 9, and 2. Which one is the exponent? 3, 9, or 2? 2 is the exponent, because logs tell me an exponent. Okay, so 2 is the exponent. Okay, out of 3 and 9, which one's the base?
3.
3 is the base, so 3 squared equals 9. Some of these you can kind of figure out by using the patterns and the numbers, but then it starts to, you start to put letters in there. You can't always guess the pattern. Some questions in the Math 12 exam have strictly been log base A of B equals C. Can you rearrange it? So don't just think you can fix it on the pattern. You should also try to learn just what the definition means. Okay, so 10, 1024, and 2. Can somebody say that as an exponent?
2 to the 10th power is 1024.
Yeah, that's right. Okay. Let's take someone else here. Ming, can you explain to me the next one as an exponent?
Is that a 3?
It is a 3, yes.
Okay, so 3 to the negative 3 is 1 over.
That is correct. Okay. Okay, let's see here. Tom, can you do the next one for me, right here? It's a 6 if it's hard to see from there.
Oh. 6 to the negative 4 is 1 over 296.
Yeah, that's correct. See? What's so hard about Math 12, right? Easy stuff. Okay, so I'm going to finish the last ones off because it looks like we're getting the hang of it. So, those would be the representations going from log to exponent. Believe it or not, those skills do appear on the provincial exam. That easy, just changing from one to the other. Okay, there's other things we need to be able to do with logs, like evaluate them. And a lot of times we don't have a calculator, so the first small set of exponents, we want to try to sort of figure them out. Like for example, if you didn't have a calculator, could you figure out what this number is?
3.
3, right. So what I'm trying to figure out is what's the exponent that connects those two numbers. So you're right, it's 3. Okay, so what exponent connects 3 and 729? Oh, that's a larger one. 5? Let's see here. Is it 5? Is it? 6? Not bad. It's still early in the morning. It's, you're not only off by 1, right? Okay. 512? Any computer nerds out there?
9.
Okay, yeah. Powers of 2. If you do lots of computer science, you'll get to know them.
It's 1024 divided by 2.
Okay. How about log base 10 of 1 over 10,000?
Negative 4.
Yeah, so I don't know if you remember that grade school trick. If there's 4 zeros, that means this is 10 to the 4. So since it's underneath it, it would be negative 4, right? What about log base 4 of 1 over 256?
5.
What's the connection between 4 and 256?
4. 6.
Yeah, it's actually 4.
I'm guessing.
So this one is going to be a negative 4. Okay. You're going to need a calculator. Whenever you see a decimal, you're going to need a calculator. So give it a try with the calculator. What a surprise, surprise. It is also negative 4.